Hello guys, welcome back. This is my third video and I hope the first two were helpful for those who watch the videos. In this video, I am going to do something different, but also not different from the second video. In the video, we did Chow Break Test on AAPL return and the data we have are from 1993 to 2010. And then we break it into two periods, 1993 to 2004, and then 2005 to 2010, to determine whether the beta of apple for the two periods are different from one another. When we did that, we got the p-value to be 0.35, which is much larger than 0.05, so we didn't reject the null hypothesis. So for this one, I'm going to use the same data and the same code, same data but not different code. So instead of using the old code, the regression that I'm going to do, I want to use the Python functions so as to increase the generality and efficiency of my code. So let's begin. As always, we begin with importing the libraries and the modules that I am going to use for this regression. So there are three libraries and modules that we have to download. These three, then. And the second step is we want to read this function. I won't read the CSV, but instead of just reading like this, I will put it into a function. So I start with definition and I give a name to the function. So I say modify df. I'm not going to input anything, and it should return me a data frame. So what is my data frame? Easy. I say pt.read CSV and the name of the CSV file, which I name as here, this one, raw apple and market 93 to 10.csv, and I say header equal to 0, index column equal to 0, and pass dates equal to true. I got it right. Sorry, I don't need s here, and pass dates equal to true, which is right. But another one I need to think about is I need to change the index, right? We did change that here too. So I will do the same here, df.index, which is equal to pt.to date time, and this is my index, and change the format as %y, %m, and then to period, which I marked as m, so that we get rid of the days in the data frame because we have the days here. That is not enough because your data frame now only have these three columns. We don't have the needed dependent variable and explanatory variable. So I need to get my dependent variable, which I call this dependent variable, and also my df, which is explanatory variable. Sorry. So to get the dependent variable, you have to minus the apple return minus df, oops, if, and df. Let me copy from here so that we save time. And I say market return minus df. Yeah, good. And with that, I can return my data frame. So no mistake. Next step is I need to specify the break year and the break month. So I say get breakpoint. So to get that, I will say I want break to happen at this year and at this month, and it should return me the break year and break month. Uh, However, you need to anticipate some problem that may arise, which is what if I happen to input the year, which is not between maximum year and the minimum year? What if the month that I put in is not between 1 and 12? So in order to handle those uh, mistake, I need to put in another two um, variables, which are minimum year and maximum year. I don't, of course, this is for the year only. For the month, it's between 1 and 12, which I know is always going to be between 1 and 12, so I don't worry so much about that. So what happened is, if the year that I put in is not between the uh, minimum year and the maximum year, or the month that I put in is not between 1 and 12, something must be done. So if not or not, which means if the year is not between minimum year and the maximum year, if the month is not between 1 and 12, what will happen? So either one of these conditions might be true. So I need to check again. If um, the year is between maximum year and minimum year, which means that what is wrong is the month, not the year. So the year is perfectly fine. So I say break year is just the year. But there is another error that I need to anticipate. What if I happen to input a number which is not an integer? So I want to round that year. Okay, and then month. So I'm going to do something simple. It is a little bit stupid, but it is a simple solution. If the month that I put in is not between 1 and 12, this function will force the month to be 6. Okay? And of course, I want to print something to alert that the month, let's just say, we don't have to be grammatically correct. So month is forced to be 6 in June. But if, let's say, the year is happen to be between minimum and maximum year, but sorry, if the month the month happen to be between 1 and 12, my break year is the year that's the problem, and the break month, no problem. So I say break month is round the month and problem solved. So again, I'm going to employ a simple solution, which is force the year uh, to be the mid-year. So which is easy. Minimum year plus what I'm going to do is maximum year minus minimum year, then divided by 2. Okay, good. And then I need to print 2. Here is forced to be mid-year. Okay, or else, what if both of these conditions are false? That means the year is not between minimum and maximum, the month is also not between 1 and 12. So I need to force both the break month and the break year. So let's do that. And the break year happen to be this 2. Good. And finally, if there is nothing wrong with the year and input month, they both are between minimum year and maximum year, and the month is also between 1 and 12, nothing wrong, then my break year become the round year, and the break month become round month. Good. Okay, understood. this might be a little confusing. I'm sure there might be a more efficient way, but let's get back to it later. My function is fine. Then the next one, I'm going to do linear regressions. So to do linear regression, I need y and x. Y is the dependent variable, x is the explanatory variable. So to do that, I need to first add the constant to x, then I can do the linear regression. Let's copy from here so I don't have to waste time. It's here already. So tab, and I don't need this though. So I add the constant, and the dependent variable is y and x and x. And what do I want the function to return? Once you do linear regression, you saw previously that there's a lot of variables that you can access, but I don't need all. For this exercise, I only need this SSR. So I'm just going to return the linear regression dot SSR, and this function is done too. Next step, I want to find my p-value. So I say get p-value. So to find the p-value, what do I need? If you remember the equation, before you find p-value, you need to get the f statistic, and that f statistic you use the SSR value, SSR or SSR1, SSR2, and you need degrees of freedom. There are 2 degrees of freedom because you're using f statistic with 2 variables, and not 2 variables. You just need 2 degrees of freedom. Now you have this. What do? You have to get the f statistic, which I may not remember the equation. I think it's SSR1 minus SSR2 and divided by df1 and and divided by SSR1 plus SSR2 and divided by df2. I may be wrong, so let's double check the equations. So previously we had the f statistic, yeah, here. Linear regression 1 over 2 plus 2, yeah, right? And with this f statistic, I can find p-value, right? And p-value is I'm going to find ss.f.sf, and I need to put in f statistic and the degrees of freedom and degree of freedom 1 and degree of freedom 2, and return my p-value. Good. Okay, so everything looks fine. So the next function I am going to because I have p-value now, so I can do the hypothesis testing. So let's test my hypothesis. To test my hypothesis, let's think about what you need to input to the function. Because you're doing Chow Break Test, there must be the break point, which is the year and the month. So this one you definitely need it. And because you're doing hypothesis, you have to specify the significant level. So I say significant level. Let's see if that will be enough. This function will not return anything because I'm just going to call in the function. So this is the main function actually. So in this main function, I'm going to make use of the function I wrote before. So the first step is data frame, which I have called it get modifying df. You have this data frame, then what will you do? you will get the gap breakpoint. Let's say break year and the break month. Because this function returns the year and the month in tuples, you will have to be careful with the a little bit careful here. If you want the year only, you will need index of 0, and for the month is index of 1, because year is written first in the tuple, so index is 0, and month is the second one, so the index is 1. Now you have break year and the break month. With that, what you can do, you can move on to the next step, which is linear regressions. So I need to find the SSR of all. This all is I call this function linear regression, and the YF is the Y is going to be the dependent variable, which is I name above here an explanatory variable for X. So explanatory variable for X. Then I will have SSR1. Before I do SSR1, because now you have the break year and the break month, you have to get the slice data. So here, previously, we got slice data in this way. But now I don't have these strings like 99, 1993. What I have is the break year and the break month. Somehow I have to convert it into a string, which is very easy. So let's say A, and say I say string break year, that is a plus, and the dash plus, and string break month. Now you have A. Once you have that, you can slice the data, and let's copy it here. So I call it Y1 and X1. But here, instead of starting from the first one, you don't need that, because if you don't write anything at the start, which means that at the first row of the data frame, instead of giving a specific date, year, and month, I put A. And here I need to change a little bit, dependent variable and explanatory variable. Okay, with that, I have SSR. I can find SSR1. Let's copy this one. This one is going to be X1, and this one is going to be Y1. Good. And give me a second. And here too, what happened is that I cannot jump immediately to this, because think about it. If my break month is 12, you will have to increase the year by 1, and the month become 1. If your break month is not 12, you don't have to increase the year, but increase the month by 1. So you will need a simple logic to get around this. So I say break month is equal to 12. If the break month is equal to 12, my B is going to be string break year plus 1 plus string and 1, because the month is 1. Else B is equal to string break year is the same plus string is break month plus 1. Good. Once you have that, you can also find SSR2 to linear regressions y2 over x2. Once you have all those SSR, all SSR1 and SSR2, what you can do, you can get your p-value. So I say get p-value. I call it p-value. If you have p-value, what can you do? You can you can make your decision regarding your hypothesis. You compare your p-value. If p-value is less than significant level, you say print, reject the null hypothesis at the significant level of plus string significant level, else print do not reject the null hypothesis at the significant level of plus string and significant level. Good. So everything look fine. I think this is the end of the function, and it doesn't give me any mistake. So now I can test my hypothesis. Let's begin with the month and the year we had before, 2004 and 12. So I say the year is 2004 and the month is 12, significant level is 0.05. If I'm right, I should get the same p-value and it should give me the same. Okay, wait, I want to print my p-value here. Okay. If everything is fine, it should give me the same p-value and same decision. So let's start. Oops, sorry. What is wrong here? Name RF is not defined. Where is it? To date time to oh, pretty stupid mistake. Okay, awesome. Yep, I always make that mistake because I should have the minimum year and maximum year, which I can get it easily. Minimum year is the data frame, get it from index, index at the year and the month after I modify it, and I need to get the minimum and maximum year to the same index dot year dot maximum. Okay. And, oh, what is wrong here again? 1 2 is not defined. Okay, I'm just not being myself. Okay, 1 2 and x2 instead of start from b all the way to the end, b all the way to the end, and let's see. D1 is not defined. P-value, df1 and df2. Okay, so degree of freedom, simple because I know the number of variable is 2, and I'm just looking at this equation, right? Notes. Yeah, observation minus 2 times number of variables. To get that value, you know, observation is the length of this data. So which is in Python, you can get it by calling the length of data frame, and I say minus 4 because 2 times number of variables, 2 times 2, 4. Okay, let's do that. So what do I get? I get 0.35689, which is the same as we got before, 3.689. Okay, so that's it. The good thing about this is that now I can just put in 6, and I can get a decision very fast. So I say 2000. 2006, I get this. Before, if I'm using the old code, I need to start from the beginning and then change a lot of things. But with the use of function, I can just change the year and the date, and I'm done. Okay, so thank you all. I hope you like this video, and if you want the code to be sent to you, I can do that. Please send an email to this address, and I will send you the code. Thank you.